Hi guys. So this presentation is just an excuse for me to search Google for images of elephants. So a little disclosure before I start. Prior to coming to Booking.com, I used PostgreSQL every day, converted a large number of my SQL apps over to PostgreSQL. It was primarily financial data and medical research data, where the consistency of the data mattered. And we had junior and senior devs working on the database directly. So we needed to ensure data accuracy at the point of storage rather than providing an API, because we had people working with Java, PHP, Perl, some C stuff. We had instrumentation that was actually writing to it with ODBC. So we needed to enforce those rules at the lowest level possible. Since coming here, I've been using PostgreSQL for personal projects, and I haven't had a lot of free time recently, so I'm a little bit rusty. So if you have questions, I'll do my best to answer them. I do know there are some people here that are, have a lot more knowledge in some of these areas than I do. So if someone asks a question and I'm like, what? If you know the answer, feel free to jump up and say anything. Always feel free to interrupt me as much as possible. So we have NoSQL, we have MySQL. Why even bother with PostgreSQL? NoSQL is kind of for free-form data, right? And these things scale really well in air quotes. They tend to be distributed. There's usually not a schema. You're not really terribly concerned with normalization, though we kind of tend to care about normalization and all of these things, but we still use these things like Redis, Cassandra, MongoDB, and Couch. And then if you're using structured data, then just use MySQL, right? Because it's web scale. So I've heard this from people professionally here at Booking, and I've also heard it outside of the Booking community at other conferences. And it's this concept that MySQL is faster than PostgreSQL. And this kind of, whenever I hear this, it bothers me a lot because if you do the wrong thing, you're going to have a bad time. And this may come as a shock to most people, but if you use technology the wrong way, you're not going to get good performance. If you look at the benchmarks between MySQL and PostgreSQL, usually the ones where PostgreSQL wins are the ones where the PGSQL DBAs wrote everything for the MySQL stack and the PGSQL stack, and either intentionally or unintentionally introduced massive performance problems for MySQL in the process. And then you flip the tables and you look at where MySQL wins, and it's the same thing. MySQL DBAs writing applications in PGSQL, which they're not that familiar with, to demonstrate that their app is better. And you end up with poor performance results in PostgreSQL. I happen to know that there are large installations of PostgreSQL all over the world doing millions of transactions per second across massive clusters. I actually worked with a guy who has a company now that does like scaled PostgreSQL instances. So if you use one technology as if it is another, yes, it's going to suck. And so you can find performance benchmarks on both sides that say it's better or worse. For me, kind of the definitive reason that I'm a fan of PostgreSQL can be expressed in this particular query. Does anyone, there's something wrong with this query. Is everyone able to read that?
Yeah.
And see what's wrong with it? These two are not enclosed in any type of aggregate function, and they're also not in the group by statement. So what happens in PostgreSQL? Well, in PostgreSQL, when you attempt to run that query, it's in the query buffer I just did enter, you get an error back saying you can't do that because you have failed to group this particular constant by. In MySQL with the default install, and by setting the SQL mode to ANSI, this is what you get back. MySQL has been successful because it makes SQL easy. What MySQL does in the background is it figures that you just forgot to apply a aggregate function and applies any to those columns. So it's really easy to spot in a small query like that, But try debugging that when you're dealing with a multi-page query where one parameter hasn't been aggregated or appear in a group by, and you still get a valid result. You can enable in MySQL the ability to fail on that, but it is a separate parameter you have to set in addition to setting, I think it has like a strict mode. You have to actually set a flag beyond strict mode.
It's another flag, only group by.
Only group by elements. Yeah, I was playing around with it because I was trying to get MySQL to fail, and there's only one flag that's set, and they removed in 504. That was included in the ANSI standard, and then they removed it in 504 from that ANSI standard grouping.
Because it's actually ANSI compliant. ANSI doesn't say anything about that.
Yeah.
So either way, it's compliant.
Yeah. But again, MySQL has been very successful because it does make things like this easy. Most of the time, those group by statements, those additional parameters that you're not including in the group by, those are labels, and so they're the same for all of the elements in the list anyways. So 80% of the time, that one optimization is going to save the programmer time. The thing that makes me weary about MySQL, in addition to this type of very loose mode of SQL interpretation, is that Oracle's now involved. They have a glowing reputation with the open source community. There's a bunch of forks right now. MariaDB seems to be the leading fork if you're looking for enterprise thing, but you do have an instance where there are some things that perform really well in the Oracle version of MySQL that don't perform well in MariaDB, and vice versa. So you may be bit by edge cases going back and forth between those. I think there's some eventual consistency that's going to be brought into the MariaDB fork, but that's something to be aware of if you're trying to figure out where am I going to go when the license changes. So PostgreSQL learned a lot from MySQL success. I originally evaluated PostgreSQL back in 2000, and it was the 7.0 branch, and I built a basic web application and I benchmarked it, and it was slow, terribly slow in PGSQL, and so much faster in MySQL. That's because there's a lot of features built into PostgreSQL that have always been there, and those features introduce additional lag. But what MySQL did well was that it was very fast, and if you were trying to make that decision, you would go with PostgreSQL no problem, or MySQL no problem. The other thing that PGSQL learned from MySQL was that open source is good, but it's nice to have commercial support as well. When you have an enterprise application, it's good to have that. So now Enterprise DB exists, which provides, and there's a bunch of other companies as well that exist that provide PostgreSQL support. So, features. There are some things that I really like about PostgreSQL that make developing with it a lot of fun, and also give me the freedom to give lower layers of access to developers than I would normally be comfortable with in an environment like HIPAA in the US, where you have patient confidentiality issues. The first is reliability. This is something that almost every database engine has implemented, which is ACID. Atomicity is that a query will fail in its entirety or be complete in its entirety. A complete failure or complete success. Consistency, that it will leave the database in a valid state and has the assurance of receiving a database in a valid state. Isolation means that you can run the query you can run any query from that state that is currently there, either in series or in parallel, and receive the same result from the same starting point. And durability means that when the transaction returns to the client, if I yank the cable back out of the database, at that point, the database has done everything in its power, to ensure that when I plug it back in, that transaction is still successful. The caveats there have to do with rates, with caches, and whether or not your cache battery is charged or not, as we found out once. It's totally open. One thing that I'm really surprised has not really gotten into MySQL more is the assortment of native data types in PostgreSQL. Just out of the box supported, you have a large selection of numeric types, different string types, dates, times, and intervals are supported. Booleans, arrays are native in PostgreSQL. I believe there is some MySQL support for arrays and something called sets as well. There's geometric, so you can do X, Y, Z coordinates and planes and select distances between points in coordinate systems. But for me, the biggest boon to choosing PostgreSQL over MySQL, working in network security, is that networking data types are native in PostgreSQL. So there's no converting from ASCII to integer and then back again. You can actually use selects the way that you would think about them in your head, and that makes being able to use the database as a debugging tool or a troubleshooting tool a plausible thing. Added in 9.2, JSON support. So now, not only do you have arrays that are native expandable columns, but you also have the ability to store a JSON document and access the elements inside of that JSON document in a table. So this is how you might use native data types. I really like this syntax. Select everything from the network where the IP is contained in this network block. I'm a network guy, so this is what I think about when I'm trying to determine IPs, not integer ranges, and I don't have to apply any unnecessary stuff. For timestamps, I can use things like now minus an interval of 30 minutes. That just makes sense to me. There's a ton more date range and date math that PostgreSQL not only does well, but does fast. So that's really nice to have when you're doing troubleshooting. And down here you can see this is an example of a new operator that was added in 9.3, which allows you to actually retrieve the value of a JSON element and compare it numerically if it's a numeric value. So you can actually get at the elements inside of your JSON documents as if they were native data types inside of PostgreSQL. I like constraints. Again, from the medical side of things, we were tasked to make sure that data entry was correct. Things like blood pressure, blood sugar, these things have to be within inside of normal ranges. You can't have someone with certain blood pressure or they're dead. So we can actually add those types into the database. We can add those checks in. The more complex the check, the longer it's going to take when you do an insert. So it's up to you to decide how complex you want to get. Just a really simple check. Happy int has to be greater than 0. If I try to insert a negative, I receive an error again. So I like that. I like the exceptions at the database level, being able to see that the database is rejecting things because things aren't normal. One of the greatest features that I think for PostgreSQL is the stored procedure implementation. It was designed to be compatible. The PL procedure language PostgreSQL is actually designed to be compatible with Oracle syntax. So you can take someone with an Oracle background and they can be relatively effective without much time in PostgreSQL. It's extensible, so you can write your own procedural languages and load your own interpreters, and that's exactly what people have done. There is a PL Perl. It's like mod Perl, so it's a shared interpreter for the entire process that is running that system, so you have to be aware and do things inside of lexical blocks. If otherwise, you may have pollution of your variables. PL Perl has no file system access. The idea is that by default, you should be able to run Perl without having to worry about someone attacking your file system from a database call. If you're interested in opening yourself up to that and you know what you're doing, you can use Perl U, which is the untrusted environment, which allows access to the file system. So PL Perl is just a stock Perl that's running and has no modules loaded that are not part of the core. It can't load modules that you've installed from the cpan. Perl U can actually load modules. Inside of stored procedures, things like triggers will return a special type of variable to the stored procedure language. And that's called the SPI. PGSPI is the interface to that, but it's a little bit archaic if you've never worked with it. And so someone wrote a database driver for PGSPI, which allows you to use native, allows you to use DDI type code inside of a stored procedure, so that you can work with the rest of the database as you normally would work with the database. So that's kind of cool. Something I started playing around with was PLR, which allows you to actually load the R interpreter inside of PostgreSQL and do statistical queries that you can't do inside of PGSQL natively using R. That was kind of a thought experiment and fun. One of the other things I did, just because I hate myself and hate everyone else, was because you can use DBI inside of a stored procedure. For the hell of it, I actually loaded DBIX class inside of the stored procedure in PostgreSQL just for fun, to know that I could do it. Here's what a standard stored procedure looks like. You can't really read that, I guess, and I can't drag things around, but you just declare the function, give it a parameter list, you declare your variables. They're passed in as $1, $2 like a bash script. Here I'm passing a variable character into an IP address. So if that fails, the store procedure will throw an exception. So if I send an invalid IP address, I will receive an exception. I declare a variable that's going to come out of the stored procedure as an integer because it's returning an integer. Look up the ID in the database. If it's not found, I raise an exception, and DBI knows, hey, you've got an exception, you've got an error, which is a good way of working, I think. And then you return the out dev ID if everything went successful. To call stored procedures, it just looks like this. You reference the stored procedure. Where it starts to get interesting is with triggers. And again, triggers are one of those features where you should shy away from them in MySQL because they were bolted on after the fact. So triggers have always been around in the Ingress implementation and came from Ingress. PostgreSQL came from Ingress. Triggers are well documented, well defined, and can be used for great good or for terrible performance as well. You can always write terrible stored procedures, but you can end up costing you in the trigger stuff. But you can write good triggers that do neat things. Like git commit hooks, you can run triggers before or after the transaction applies. So if you do it beforehand, you can actually change the values going into the database without having to do another write to the database. If you do it after, you would actually have to do an update statement to update the row in the table. You can also return an exception from a trigger before the update applies or before the insert applies or create whatever operation it is, and that will block that transaction from occurring. And it will that exception will go through the stack all the way up, and you'll stop execution of the transaction, and the transaction will be reverted. That's the other nice thing about raising exceptions when you hit an error condition, is that you can actually guarantee that transaction will stay throughout your entire application. Something cool that was added was there's now triggers on DDL changes, so that if someone changes the schema of a database, you can actually trigger on column drops. So let's say somebody drops a column in a database, you can actually implement a trigger that would archive that entire column, that all of the rows in that column, out somewhere else, or maybe dump it to a flat file or something. Massive performance hit, but if you really wanted to be sure, you could check to see how many rows were changing in that particular schema change, and if it affected too many rows, you could then just toss it out into a file, that way you wouldn't lose data. Here's an example, trigger function. Triggers return trigger, which allows it to know whether or not it should proceed with the next transaction. This is an example using the untrusted Perl. And what I had was a database of IDS alerts that were coming in from Snort. And anytime I saw a new signature, I wanted to get an email about it, because new signatures happened infrequently. New events happened very frequently. And I was able to then classify those events in the system to know whether or not I care about this one or just ignore this type of alert. So this just basically sends me, would send me an email when a new signature happened. So you can see the _TD gets passed in. It has two values, the new and the old, and there's a few other values that allow you to manipulate or to work with the table structure that's in PostgreSQL, and you can just retrieve out arbitrary columns and format the email and go about your business. You apply a trigger very simply. You tell it when to run. This one runs after insert, so it will never block an update to the database. And it runs on each row. So every row that's inserted will have this sort of procedure called. Any questions? Views are nice. we used a lot of views because, again, we had lots of reports, and we would optimize the queries in those views so that the reports would be fast, and then we could just hand those over to a junior dev, and they would be able to run them without annihilating the database. There's a concept of like static versus dynamic. Dynamic view is usually just a view. A static view would be something like a materialized view. The views are actually writable by triggers because views support the same events that tables support. They just don't do anything with those events. You can actually write a trigger that will intercept that data and do something with it. So if you have an incredibly complicated view that you want someone to be able to update, you can actually do that. Or if you want to have a subsection of a table you want to expose to someone, you can give them access to that by giving them access to the view. There's a new feature actually that makes this a lot easier. But by far, the best feature of PostgreSQL that I've come across, being a terrible, terrible programmer and a terrible database administrator, is this PG-stats functionality, which is essentially metatables that track all the usage of your database and the performance characteristics of each particular metric. So here's one query that I run very frequently. I created it as a view in most of my things. It's a simplified version, so it fits on this slide. But it gives me the table name, the index name, how big the index is, the number of times the table has been index scanned, and the number of times the table has been sequence scanned. So that I can see, okay, I have a really large index, and the table is never index scanned, or this particular index has never been used. This actually gives me the table, the index name, the number of times the index has been used, the number of times the table has been sequence scanned, and the size of that index. So I can optimize and drop indexes that are large and not used, or find that there's a table that is being sequence scanned a lot and start investigating what queries are being run and how can I write a better index for that table. There's a ton of statistics, and those statistics are used not only by user or by mere mortals, but also by the query optimizer itself. So one thing that I'm really not, I was really surprised at was the way that MySQL does explains, because I was used to coming from working with PostgreSQL, working with MySQL again. I didn't really grasp the explain stuff. So here's a query. Does a whole bunch of aggregation. It does some joins and even does an exclusion on the joins requiring that we have more than 2 distinct days in this query. This is from an open source project that I work on for monitoring DNS traffic. And there's two features. So first there's explain, which is what you think you'll do. So based on the statistics in the PG stats table, how would you implement this query as the query optimizer? So you get each step stepped in, you receive the cost that it assumes it's going to take, which is the number of milliseconds, I think, that it's going to take for this particular thing, the number of rows that are affected, and the width of those rows. So how many columns are in that set. And it tells you each step of the way what is taking what amount of time in this particular query, so that you can figure out, well, this isn't really that big of a deal, but this is looking like it's a little bit more of a problem here. So maybe I need to do something with that. So that's all well and good, and MySQL gives you the same type of analysis, so you can see this. But I was surprised to find, and maybe I'm wrong, but the last time I asked anyone, this did not exist in MySQL, which is, okay, you told me what you think you'll do, now do it and report back what actually happened. Because sometimes the optimizer is completely wrong. And when you see enormous differentiations with these particular assumed costs and the actual time it took for something to occur, you may need to reanalyze your tables or vacuum or something like that to better understand what's happening. But you also get things like the amount of memory that were used for the sorting, how many buckets were used in the hash lookup, and the total memory usage to create that hash lookup. So you get really in-depth statistics about what is occurring on that particular query, which is invaluable as you're sitting there trying to figure out why this thing is killing the database server. So David Wheeler, has been really great for the Perl community. He's created a lot of really cool Perl modules like DBIX connector, and there's a ton of other ones that I've used. Known his name for a very long time. He runs a blog, justthetheory.org, and he was looking at the PostgreSQL community, and he's like, you know what, they're in need of a modular system. So he created this project called the PG Extension Network, which is modeled after Perl CPAN, to provide a way for people to upload stuff to a central site and to be able to install it in PGSQL without having to leave the system. So if you have a user that has that access, you're able to install extensions. And there are a ton of extensions. There's a bunch of procedural languages that you can use. There's PL Python, PL Perl, PL TCH. There's a bunch of PLSH. There's a bunch of interesting procedural languages you can use inside of PostgreSQL. One of the best known projects that's an extension for PostgreSQL is the Geospatial Information System extension for doing mapping data, so that you can actually install latitude and longitude coordinates and calculate, find me the nearest such and such. It's pretty neat. T-Search 2 was pretty cool till I learned about Elasticsearch and started using that for full text search. And L-tree is neat because I was working on a project for DNS monitoring, and DNS has a tree structure, and that's really hard to fake in SQL. And L-tree actually allows me to create a column in my database which holds the tree structure for that particular record, and then I can do queries using tree filters that then check to see if that tree matches this tree, and so on and so forth, which is surprisingly fast, faster than I expected it to be, and works really well. Since 7.0, when most people looked away, there's been some really cool things that have happened in PostgreSQL. I want to start at 8.4 because I didn't want to go too far back, but windowing functions were added in 8.4, and this allows me to basically look at a particular aggregate function over a subsection of that query. Not of that query, it doesn't have to be included in the query, of that table. So in this case, I'm partitioning over department, so I'm going to get my person, department, salary, average salary over the department. So I might have something that looks like this with name, department, gender, and salary. And so when you do average salary by department, cast it to an integer so that it doesn't have a million floating point values, you can see that for accounting, here's the average department salary with the record, and then down here, the IT department is a little bit higher paid. It's kind of cool, it's kind of fun, you can combine these multiple ways, and much like group bys, you can include multiple ones, and you can ask some really dark questions about what about gender, what about department and gender. You can do things like, combine all this data together and use math to figure out who's the highest paid or whatever. So it's kind of neat to have all that data available, and this is actually very quick. It's much quicker than running this query, running 3 queries to do this, or this would be 4 queries that you would have to do to get this data and then the salary broken out by these things. Yes?
You're aware that this particular query you can rewrite using subqueries, which will be just as fast and work on any engine, including like SQLite and stuff.
Yes, there are other ways to accomplish the same thing.
Okay.
Yes.
Windowing
is just a fancier language and is really just more pretty to do than stuff. You can actually declare separate window statements in your query after the from to tell it which attributes you want to window, and you can give the window an alias. That way, if you're using a particular window for a lot of different computation, then it becomes quicker to write that query than it would to rewrite this query using subqueries. So it's kind of just syntactic sugar for...
Or just use DBIC to write your subqueries.
Yeah. In 9.0, some unavoidably neat features came up, which is hot standby for master servers, and streaming replication, which is very similar to the way that MySQL does replication now. Triggers were improved, so you can trigger on when. This is the artifact of ORMs. Lots of popular ORMs in Python, Perl, and Ruby will play stupid and not keep track of which attributes in that object were actually modified, so that when you do a save, it sends all the data through. And you can imagine that that is a little bit, that's very consuming on a database server if you're writing the same data over and over to that column, because that update is going to fire, and that is technically a new field. So you can actually check with when those attributes change, so that you're not running the trigger when the thing stays the same. You do column-based triggers, and you can do deferrable constraints. This is neat when you have, let's say you have an ID, and this is just the simplest example, and this is a terrible thing, you would never do this. If you had an automatic incrementing ID that had a unique constraint on it, if you were to write a script that did update ID equals ID plus 1, and you ran that, it would fail instantly, because the unique constraint would fail, because the first time you hit, you have ID 1 and 2, and then you go and you update 1 to 2, well, now you have 2 2s, so it fails. The constraint is immediate. What deferrable does is it says, evaluate the constraint once the transaction is completed. So if we update everything and add 1 to everything, by the time the transaction is done, everything should be unique. If it's not unique at that point, then yes, fail, by all means. But wait until that point to figure out whether or not it's failed. It can be more expensive because all those operations have to occur, and then a revert may or may not happen. But if you need that type of functionality, it is available. There's also anonymous functions now, named parameter calls, and exclusion constraints, which are kind of interesting. So let's say first you had a reservation site, and you had a room ID, a guest ID, and a during, which was their stay, which is a date range format. You could add a constraint to the database that would allow you to say, use a gist index to exclude any new records from coming into this table when the room ID is the same, and during overlaps. This is the shorthand for overlapping, double ampersand. So now, without you having to write any of your application logic, you can actually have the database attempt to insert, and when it fails the overlap with the same room ID, it will bail with an error and tell you. So it's just a little bit of syntactic sugar that's kind of neat with the date range format. In 9.1, synchronous replication was added. PGXN support was added to the server, so you could actually use it inside of PGSQL. The creation of unlogged tables occurred, so now we're not going to use the write-ahead log for tables if we want to with this unlogged feature. This would be basically just dropping the table's reliability down to that of like MyIsm in MySQL. So you can say, just don't use the write-ahead log for these tables. It's faster, but it's so more dangerous. The first open source database to integrate fully with SE Linux, and we added in the ability to communicate with external data sources into PostgreSQL. So now, through PostgreSQL, you can connect to MySQL, Oracle, Sybase, Couch, blah, blah, blah. What's really cool is you can connect to LDAP. So you can query LDAP servers by just using a connection to a database server, and you can even include that in some of your check constraints or into stored procedures, views, things of that nature, which is actually kind of handy for something that we're working on here. And you can also include sources that are websites. So you can pull down JSON data if you want to, or full HTML pages and provide them as views in your database. I don't know why you want to, but if you want to, you can. Enough rope to hang yourself. 9.2 is a bunch of performance increases. One of them was the index-only scan, which is if your query can be satisfied with only data available in the index, it will return without referencing the table. It's something that's also been added to MySQL as well. The JSON data type was added, range types were added. 9.3, you can now create a custom background worker process in PostgreSQL through the extension language. So if you have a maintenance task you want to run in your database, you can do that. Materialized views are now native in PostgreSQL, so all you have to do is say, create materialized view, and your view becomes instantly materialized as a table in the database. It is not updated until you either analyze the table or issue the refresh materialized view name command, But this is now a native implementation. You don't have to write any code to maintain it. All you have to do is tick that thing. And that's what maybe you might use a custom background worker for, is to say, create a automatic materialized view refresher script that sits in the background and then automatically refreshes those views. The native JSON operators were added in 9.3. Recursive views are now possible, so that you can do views that create tables that are infinite, if you'd like. I don't know why you want to do that, but you can. And simple views are now automatically updatable by default. So if you expose a simple view that's just maybe a subset of a table, and somebody attempts a write or update to one of the records that shows in that view, then it will actually proxy that write back to the table that has that data. They would have to have write access on the view to be able to do that. And then some also cool things in PostgreSQL that make it more of a programming language than I feel MySQL is H stores. You can do key value stores in PostgreSQL natively, like the NoSQL stuff, but have all the additional reliability that's built into PostgreSQL, which may be relevant for your business. Custom data types, you can just create type blah and then define how that type looks. You can create composite data types, so you can actually store a row as a column if you wanted to do that. Like C structures, you can tell it this has these attributes. You can do partial indexing, so you don't have to index a full table. You can just maybe index the last week worth of data, and every time that index is refreshed, that constraint will be applied. You can do namespaces, which is how a lot of people were doing materialized views before it became native, which is creating a private namespace in the same database, which keeps track of where the materialized view has, when it was last refreshed, and the contents of it, and provides a view interface backend through the private namespace. And you can partition, using these types of control mechanisms, you're able to then create a table, like a log table, where you can actually read the parameters of that table, the selects of that table, and figure out that it actually maps to other tables. So you can partition by date, or you can partition multiple records using some seed value, which is one of the ways you can scale up a PGSQL instance. So that's kind of my crash course in PostgreSQL, why I like it. Questions? None. You can do JSON. It's web scale.
Yes, I have a question.
If it's just one, you're lucky.
Just one. In the very beginning, you mentioned that you're pretty unhappy about MySQL needing to turn on strict mode, to be careful with your data and stuff like that. And maybe we'll say this, most of these people actually program in Perl, which also needs use strict in order, to be useful and everything. So how to explain that?
The programming language, you can, so for me, especially in my last environment where it wasn't quite as, I wasn't working with quite the caliber of people that I'm working with right now. To give a junior developer the ability to write SQL was a potential I'm coming in for the next few weeks and every night and during the weekend to keep this system up and running because they don't know what they're doing. So for me, it's kind of, I see the two of them as like MySQL as the PHP and PostgreSQL as the Perl. Yes, you do have to turn on strictures in MySQL, so there's a similarity there. So it's like Perl with strictures enabled. For data, I'm very concerned about the consistency of my data at the data storage. If I cannot guarantee that my data is safe in the data store, then a lot of problems become bigger problems for me, especially when I'm dealing with security, privacy controls, access management, all of these things. It's a lot easier when you can trust your data store some to wrangle in some of the bad behavior and wrangle in some of the junk data that may end up there. It won't work at every scale, right? So we can't just replace MySQL here with PostgreSQL because we're doing some really abusive things that rely heavily on the way that MySQL works. We couldn't just, without doing a massive amount of work, replace it with PostgreSQL or something like that. But if I was creating a new system that had to store sensitive data, and I had a reason that I could use PostgreSQL, I would use that over MySQL just because of the level of control.
Well,
I have different expectations for code and data stores, I guess. Questions? Vegetables? You guys have to start bringing around vegetables. I don't know if there's anything in